Hi, ladies and gentlemen. Here's our agenda for Friday, December 18th. We are almost to break, but before we get to break, there are a couple things we need to get taken care of first. So, first of all, I just wanted to remind you guys that yesterday or on Wednesday, we completed and turned in our chemical reactions lab. We finished this week the analysis on Monday and Tuesday, and then on Wednesday and Thursday, we did the clear think map and then we turned it in. So make sure that's submitted. The other thing that you guys did this week was you completed your independent chemical reactions, or you possibly did that last week. Some of you guys did Mentos and Coke. Some of you guys did baking soda and vinegar. Some of you guys baked cookies. Some of you guys baked bread or cinnamon rolls. And you are now in the process, or maybe you finished, creating a video to explain your reaction. Okay, so today your goal is to finalize those presentations. Again, you can either use the template that I created, or feel free to make your own. You can use WeVideo or Screencastify. If you look at the assignment, the independent chemical reactions assignment, you'll see that there are tutorial videos on how to use WeVideo and Screencastify. Or go ahead and Google, how do I use Screencastify or WeVideo? And you can see some longer or more in-depth videos if you're looking for that. Okay, the second thing for today, if you're interested in earning some extra credit, there are 2 extra credited puzzle videos. They review chemical reactions and balancing equations. So they're a great review. They also compare chemical versus physical changes. Okay, I would recommend doing that first prior to retaking the chemical reactions quiz number 1 if you're interested in doing that. And then anything you are missing. Makeup work is due by Tuesday. That is the day before winter break. So make sure you turn in anything that you happen to be missing and submit a late work form, so that I know that it has been turned in. Also know you can always resubmit if there's something that you didn't score well on and you want to improve your grade. Again, if you do that, just make sure you fill out the form. Here's the key items from the last couple of weeks, the key ideas. First of all, we looked at chemical versus physical properties. Physical properties, stuff we can see, taste, touch. And then chemical properties have to do with reactivity, how the substance reacts with something else. And then we investigated chemical versus physical changes. Remember, physical changes, we don't get anything new. And a physical change versus a chemical change, we get new substances because the bonds between the atoms are breaking. The atoms are rearranging and new bonds are forming. When we look at our chemical reactions, on the left side of the arrow are our reactants. That's what we start with, and our products are what we end with. They're on the right-hand side. And then when we try to figure out how many atoms are involved in a reaction, we look at something called the coefficient. The number out front is the coefficient, and the subscript. So in this case, on the left-hand side of this arrow, I have 2 oxygen molecules. That means that I have 2 times 2, the coefficient of 2, subscript of 2. 2 times 2 gives me 4. I have 4 oxygen molecules on the reactant side. Over here, this 2 applies not only to the hydrogen, it also applies to the oxygen, because it's telling us there are 2 water molecules involved in the reaction. So the coefficient is the number out front. The smaller little number, that's after the symbol, those are called subscripts. So when we try to figure out how many there are of an atom, we take the coefficient times the subscript. And if there's no coefficient, it's a 1, like there is in front of CO2 here. It's imaginary if there's nothing there. And then if there's no subscript, it's also a 1. So in this case, it would be 2 times 1 oxygen, related to this water molecule. So there are 2 oxygens because we have 2 waters. The other thing that we talked about is that equations must be balanced, same number of each type of atom on both sides of the reaction equation. Okay, so if we come back up here and we try to decide if it's balanced, okay, I see that there are 4 oxygens over here. 2 times 2 is 4. I have 2 oxygens on the other side associated with carbon dioxide and 2 associated with water. That gives me 4. Okay, then I have 4 hydrogens. Okay, 2 times 2 is 4. 4 hydrogens over here, 1 carbon and 1 carbon. This equation is balanced because all of those atoms are balanced, even though they're now being used to make new products over here on the product side of the equation. Okay, and that is the idea of conservation of mass, or the law of conservation of mass. What I start with in terms of the atoms and in terms of the mass, I'm going to end with in a reaction. Okay, so this just shows it visually. If I start with 100 grams of muric acid, I'm going to end up with 100 grams of product. Okay, in this case, the products are mercury and oxygen. Okay, if I total their masses, it will total the mass of my original reactants. Okay, so I've got 100 grams on the left and 100 grams on the right. All right, ladies and gentlemen, good luck on the retake if you choose to take that. Let me know if you guys have any questions through Google Chat, or come see me during our Zoom meeting today. Hope you guys have a fantastic weekend. Can't wait to see you on Monday and Tuesday, last day before break. Bye.